Okay, geometry. We need to go back and we need to talk about surface area and volume as a whole. So when I look at all the shapes in general, not just those with a circle, but any type of shape. So this is going to take us all the way back to our quadrilaterals that we talked about way back in the fall. The square, the rectangle, the rhombus, the kite, the trapezoid, all those, as well as triangles. And any other regular polygon that we might come into, or any other polygon that we can come into. So we're going to talk about surface area and volume as a whole, just because it kind of goes with those at the circle part there, and that's going to kind of finish up our unit here. So let's get started here. The first thing I want to show you is the formulas for area of polygons. So if we have a triangle, we know we have all those formulas for the triangle. Area of a kite, all we need are the two diagonals, and we can multiply them and divide by 2. The parallelogram, we know it's just a base times a height, and that height is perpendicular to the base. In the case of a rectangle, it's length times width, or base times height, because the base and the height are the length and the width. Any regular polygon, the formula says it's 1/2 AP. That A stands for the apothem. So let me kind of sketch it in here real quick. The apothem starts at the center of the polygon, and it goes to the side of the polygon, and it's perpendicular to the side. That's the apothem. That little length right there. That little length from the center out to the side. In essence, what it is, it's kind of like a height of a triangle. Because when I look at this formula, 1/2 AP, well, P stands for the perimeter. See down here, it says perimeter, and the A is the apothem. Well, the perimeter is just a distance around the polygon, the regular polygon. So what I'm doing is I'm creating little triangles here that match up to each side. So that A is the height of that little triangle. That's what it is. That's the apothem. Okay, so I take the apothem times the perimeter times 1/2. If it's a rhombus, it's a rectangle, so I can take the base times the height. If it's a rhombus, it's kind of a special type because they have perpendicular diagonals. I can multiply the diagonals and divide by 2. If it's a square, I can take the side length and square it. Or I can use those formula for the rhombus. If it's a trapezoid, it's 1/2 of the height plus the sum of the bases. And if it's a triangle, again, we know it's 1/2 the base times the height, or any one of those formulas that we have. I do have a sheet that has all these formulas on it. If you want one, ask me for it. And it has a bunch of other stuff as well that you'll probably be upset if you see it all. Okay, so prisms and pyramids is where we got to start talking about. Prisms are similar to cylinders. Pyramids are similar to cones. The difference is they're made from polygons. So here I have a ton of different ones. Now the thing to note is on a prism, we have what we call 2 bases. And they are congruent parallel faces. So when I look at it on these first 2, the kind of what looks like a cube and what looks like a rectangular prism, also known as a cuboid. So this is a rectangular prism, also known as a cuboid. Information for you to go later with. Their bases could be any one of the 6 faces because they're all rectangles. The other one here, like this one here, I have 2 of these pentagons, one on top and one on the bottom. Those are the bases. For this one, I have hexagons top and bottom. So I refer to this one as a pentagonal prism, and this one as hexagonal prism, because that's the shape of the base. Where this one on the bottom has a triangle on the end, that makes it triangle space, so it would be a triangular prism. Okay, all the other faces are either going to be parallelograms or rectangles, depending on if it's a right prism, which means that the lateral faces are perpendicular to the bases, or they will be parallelograms if they are kind of askew. And all those other rectangle, those shapes, are called lateral faces. So they're the ones that connect the bases. And typically they're rectangular in shape when we have a prism. Now, in the case of a pyramid, again, we don't have two bases, we only have one base. And it depends on the shape of the base, on what we call it. You know, like this first one here, I would call it a triangular pyramid because the base is a triangle. Or the second one, I would call it a square pyramid or a rectangular pyramid, depending on how you want to refer to the bottom. Then we got a pentagonal prism, and we have a hexagonal prism, and I got another hexagonal prism down there with numbers on it. Now, they only have one base, and the lateral area, or the lateral faces, are all triangles. They're all triangles. Now, how can I see these more individually? Well, what I could do is I could look at what we call the net. And I think I got stuff that is overlapping here. Let me move these things out of the way here for a second. We'll get to that in a minute. Okay. So let's take a look at this hexagonal pyramid right here. If I take it and I flop all those triangles off, it looks like this. This is called the net of that pyramid. I still have the same hexagon on the bottom. I still know that it has an apothem that's 13 and a side length that's 15. So I can find its perimeter by taking 15 a side length times 6. And I can find its area by taking 1/2 times the 13 times whatever that number is. And that's how I'd find the area of it. Now, I also noticed that here I have a 22. Now that would be the slant height if we think about a cone. So on a cone that was a slant height, it's going to be the same thing here. Now, since that's the center, that apothem goes to the center, I also have an apothem that runs right there, and I have a height of the pyramid that runs right there. So again, instead of a radius, we have an apothem. So the apothem squared plus the height squared has to equal the slant height squared. Now there's so many different right triangles that could be made here. You could go from the corner of the deal, in which case I would have a radius going in, and then I wouldn't have the slant height of the triangle on the side, but I would have an edge length. So you got to kind of watch out for those. But again, we get a right triangle that forms out of that. Now, if I make a, say I had a pentagonal prism like I have here, and I made its net, notice it's got the two bases. And this lateral area, or these lateral faces, are all these rectangles down the middle. And we have again, we have the apothem and we have a side length. So those are all the different types of shapes that we have there. Now, here's what we know. We have prisms, two bases. We have pyramids, one base. Prisms, lateral faces, rectangles, or parallelograms. Pyramids, lateral faces are triangles. So how do we figure out the surface area and the volume of these? Well, the surface area of any prism, irregardless of what it is, if it's a right prism, it's going to be, well, it doesn't matter what kind it is. It's going to be two bases, and we're going to let B equal the area of the base. Plus the perimeter of the base times the height. So the perimeter, P is the perimeter of base. And H is the height of the prism. I'm going to say of solid, because that'll play in over here. Okay, so the surface area of any prism is 2 times the area of the base, whatever the bottom is, because there's 2 of those, plus the perimeter of the base times its height. What that does is, when I look at that, the perimeter gets me this length here of that giant rectangle. And then the height of the prism is the height of that rectangle. And then I have to have those 2 bases that I add on. Now in the case of a pyramid, I see I only have 1 base, and it's kind of like the cone again. I have all those triangles that all have the same measures. So if I take 1/2 the perimeter times the slant height, I have the surface area of the pyramid. Now, volume's pretty simple. Volume is how many cubic units will it take to fill that whole space up. So volume will always be the area of the base times the height, no matter what, for a prism. Area of the base times the height. Now, for a pyramid, it's not quite that easy. I have to take the area of the base, I got to take it times the height, not the slant height, but the real height, but then I divide it by 3. And why 3? Because it takes 3 pyramids to fill up a prism of the same size. Now, there is a formal proof. If you want to research that formal proof, you're more than welcome to. Otherwise, I can talk you through it or show you how that kind of works out. But those are the general formulas for any prism in a pyramid. The B and the P all are dependent upon what shape is that base. That's the important part. What shape is that base? So, those are your formulas. Let's try to do some problems here real quick. So, here I have my different shapes. Here I have 3 different prisms. Now, the first thing I do when I look at any one of these is I look at the base. What is the base? And the base here is a pentagon. So to find the perimeter, I take 5 times, well, what's the length of the side? 10. So my perimeter is 50 kilometers. Important to know. Okay, so now surface area is 2 times the area of the base. 2 times the area of the base. Well, the base is a pentagon, which means I need to use this formula for a pentagon. So 1/2 the apothem 6.9 times the perimeter of 50 plus the perimeter, the 50, times the height of that whole prism, which is 11. This has to be the height because that's the distance between those. So now I just need to multiply that out and I get my value. So my bases come out to be 345 and my other is 550. So altogether I got 895 kilometers squared. Now the volume, I just need to take the area of the base times the height. Well, the area of the base is 1/2 times 6.9 times 50. Multiply that by the height of the prism times 11. Run that through my calculator, I get 1897.5 kilometers cubed. So if it's a regular pentagon or a regular polygon on the bottom, I have to use the 1/2 app formula to find the base. Okay, let's take a look at the next one. My base is this triangle. Notice there's a right angle there. So to find the area of that triangle, I have to take 1/2 the base times the height. Well, the base and the height have to be the 2 perpendicular lengths, so it has to be the 3 and the 4. So my base, but I got 2 of them, it's going to be 1/2 times 3 times 4. And then I have to take the perimeter of the base, so I've got to add those 3 numbers up, 3 plus 4 plus 5, and multiply that by the height or the distance between triangles. There's my height. I'll multiply that by 1. So 1/2 times 3 times 4 times 2 would get me a 12. And 3 plus 4 plus 5 is 12 times 1 is 12. So I get 24 square feet of surface area. And the volume is the area of that base, so 1/2 times 3 times 4 times the height of it, so the distance between is 1, so I get 6 cubic feet. Okay, so now let's take a look at the last one here. It happens to be this shape right here. Well, that shape right there is a trapezoid. So to find the base, I have to take 1/2 the height of the trapezoid, which is this line right here of 3.7. Now we got to make sure we don't think about the height of the trapezoid and the height of the prism in the same way. This 8 is the distance between trapezoids. That's the height of the prism. Okay, so the 3.7 is the height of the trapezoid. Now, according to the formula for a trapezoid, I'm supposed to take half the height times the base 1 plus the base 2. So 4 plus 7. And then I've got 2 of those plus the perimeter of this. So it's telling me I got a 4 on these side lengths. So my perimeter is 4 plus 4 plus 4 plus the 7. And I'm going to take that perimeter times the height of the prism, which is 8. So 3.7 times 4 plus 7, I should have just been able to do that, times a half times 2 gets me 40.7. And the perimeter times the height will get me 152. So I get 192.7 square inches. Not a very good 9 there. For the surface area. Now the volume is the area of the base. So 1/2 times the 3.7 times the 4 plus 7. That's the area of the base, times the height of the prism, the distance between. So if I take that 40 sorry, it's not 40.7. The 20.35 times 8, I get 162.8 cubic inches. So there's my surface area and volume of prisms. Now, if it's a pyramid, I'm going to do the same thing, but I'm going to use the pyramid formula. Now, in the case here, I had an equilateral triangle on the bottom here. But since they gave me the whole height of it, I know that value. The difference here is I have to use some right triangle trig to figure out the actual height of my pyramid. Now, we're told that distance length of the apothem is 2.6. Hold on just a second, let me check time. Okay, I'm going to make a second video up for the pyramids itself. So go ahead and watch it.